Welcome to Ask and Learn.
In this question, we are told about an organic anion that is found in most common detergents, and we assume that the anion undergo aerobic decomposition in the following manner based on the chemical equation. So if we have 2C18, H29, SO3 minus aqueous will react with 51 moles of oxygen. Aqueous condition to produce 36 CO2 plus 28 H2O. Liquid, and this is also aqueous, plus 2H plus aqueous plus 2 SO4 2 minus aqueous. So the question is asking us what's the total mass of oxygen required to biodegrade 10 grams of the substances. So if we have 10 grams of the substance, what mass of oxygen will be needed? So we are looking for this, represented by X. Okay, so one thing we need to do is to determine the molar mass of C18, H29, and SO3. So C18, H29, SO3, molar mass will be, carbon is 12. So 12 times 18 will give us 216. Hydrogen is 1. 1 times 29 will give us 29. Sulfur is 32. So we have one of it. And oxygen is 16. And we have 3 times 16 times 3 will give us 48. So we sum them all together. 216 plus 29 plus 32 plus 48 will give us 325 grams per mole. So we'll put that here, 325 grams per mole. And oxygen we know to be 32, because 2 times 16 will give us 32 grams per mole. Okay. So from this equation, mole ratio of reaction is 2 to 51. So number of mole of this 10.0 gram will be what? So that will be 10 divided by 325. So the number of mole will be 0.03076 mole. So since 2 mole of this requires 51 mole of oxygen, how many mole of oxygen will require 0.03076? So call this, you can call this Y. So we just cross multiply. So Y will be equals to, of course, this is mole, this is mole. So Y will be equals to 51 mole times 0.03076 mole divided by 2 mole. So Y will give us 0.7846 mole. So since we know the number of mole is mass divided by molar mass, so if we want to determine the mass of oxygen that will need this 10 grams, since the 10 grams is this mole, and we know that will need 0.7846 mole of oxygen, we can determine the mass of oxygen that we needed, since we know the number of mole of oxygen, and we know the molar mass of oxygen to be 32. So mass of oxygen needed would be equals to the molar mass, which is 32 grams per mole, times the number of mole, which is 0.7846 mole. So this will give us 25.1 grams of O2.